All right, hello again, Algebra 2 people. So first of all, I apologize for wearing a hat today, but it's a little bit on the cool side in my classroom, so just trying to stay warm. Today we're going to be talking about a piece of the quadratic formula called the discriminant. What the discriminant is just this inside part of the radical. So we define the discriminant as b squared minus 4ac. Okay, and what that does is that allows us to determine some properties of the quadratic without finding the actual solutions, right? So I'm going to do the video a little bit differently than I did in class. What I did in class is I gave my students time to kind of figure all of these things out on their own, and then in the end we said, okay, well, when this happens, this is what we can say about the function given this kind of discriminant. Obviously, it'd be a little bit harder to do this on a video, so I'm going to run through and just kind of explain how I'm getting the different values in the table, and then I'll summarize everything at the very, very end. Okay. So just like always, we know our a, b, and c values. So on the first one here, 1, -6, and +8. And we know from a while back, we know if the a is positive, we know it's going to automatically open up, right? So that's okay. Now, discriminant, again, all we care about, this is not solving. I want to make that clear again. It's not solving. It's just finding this discriminant value and then seeing what happens after that. So in this case, my b squared would be -6 squared minus 4 times 1 times 8. And that is equal to 36 minus 32, which is 4. Okay? Now what that means, and again, what I had my students do in class was, as kind of an exploration, was now they know the discriminant, graph this on like Desmos or a calculator or whatever, and then just see how many X-intercepts it has. And if you do that on this one, you end up getting 2 X-intercepts. Okay? And what happens, we talked about this too, right? We know that the x-axis, those are all real numbers. So if it's touching the x-axis, that means they have real solutions. Okay? So we do the same thing on the next one. So again, a is 1, b is 2, c is 1, then it opens up. The discriminant is 2 squared minus 4 times 1 times 1, which is equal to 0. And if you graph that, it turns out that there's only one x-intercept. In fact, that means that the vertex is sitting right on the x-axis. So if you graph it, it looks something like this. So that x-intercept is going to be at the vertex. Okay, but again, I don't care if it crosses or if it just touches, it is still an x-intercept and it's still a real number. Next example, again, opens up again, but now if we do the discriminant, we see that the discriminant this time is equal to -5, 16 minus 20. Now, if you graph this, that means you're going to see no x-intercepts. This parabola is going to be completely above the x-axis. Okay. Now, a couple weeks ago, if we saw a parabola with that never touched the x-axis, we would have said that it had no solutions. But this is not a couple weeks ago. Now we know that it may not have any real solutions, but if it doesn't touch the x-axis, that means it still does have 2 complex solutions. Okay? So I'm going to do the same thing on these last 2, then I got 2 more on the next page, and then we're just going to kind of summarize, based on this information, what we can say going forward about the discriminant and what that tells us about how many X-intercepts and how many solutions it has. So keep on going here. So 1, -6, and 9. This is another one where the discriminant is equal to 0. And again, if you graph that, it's going to have one solution where the vertex is sitting right on the axis. And again, that's going to be a real solution. Anytime it hits the x-axis, it's automatically going to be a real solution. The next one, a -1, B is 2, C is -3. Remember, this time, this is the first one we've had this. If A is negative, that means it's opening down, so it's upside down, basically. Discriminant. That's going to be 4 minus 12, which is -8. And if you graph that, that's going to be completely below the x-axis. So again, never doesn't have any x-intercepts, which means it has two complex solutions. My last two examples, again, very similar stuff. So we got 2, 7, and 3. 7 squared minus 4 times 2 times 3. So that's 49 minus 24, which is 25. Graph that, you have 2 x-intercepts, which means they're real. In fact, because this is a perfect square, that actually means not only are they real, we can actually do a little smaller subset of this, and we can call them, we know they're going to be rational zeros. You don't necessarily need to know that. The main thing I'm worried about myself is that you know there are difference between real and complex solutions. But if your discriminant is a perfect square, it also tells you that your solutions are going to be rational. Okay, and then the last one, my A is negative, which means it's opening down. And my discriminant this comes out to be 169, that's 121 plus 48. And again, if you don't know your perfect squares beyond 12, that's 13 squared, that's also a perfect square. So again, 2 solutions that are real and rational. Again, if you're a student of mine watching this video, I'm not overly concerned about the rational part of this, but if you're watching this just kind of at random from another teacher, they may want you to specify when you have rational roots also. And again, that's when you have a positive discriminant that is also a perfect square. Okay? So I'm going to swing back to the other page real fast and see if we can find some patterns and make a general statement. So the first question, how many x-intercepts when the discriminant is equal to 0? Well, when it's equal to 0 was this guy right here, and then the other one right here. And that happened, whenever that happened, that gave us 1 x-intercept. So we can say that as a general rule. So if the discriminant is equal to 0, you know you're going to have 1 x-intercept at the vertex. Which means you're going to have that one solution is going to be a real solution. Okay? How about when the discriminant is greater than 0? So that was these two for sure. And we had a couple more over here. So greater than 0 right here. And then the last one, oh, actually that was only one on the front page. So on all of those, on the very first one, and then on the last two, all of those had, come on, there we go. All of those had 2 X-intercepts. So we can, again, say that in general. Anytime you have the discriminant greater than 0, I don't care what it is, 4, 18, 207, anytime the discriminant is positive, you're going to have 2 X-intercepts, and they're both going to be real solutions. Again, they might be rational depending on if your discriminant is a perfect square. But they're definitely going to be real. Whether they're rational or irrational doesn't matter as much. And then lastly, what happens when the discriminant is negative? We had 2 examples like that on the previous page. So anytime your discriminant is negative, remember what that means is your square, the number inside of the radical, inside the square root is going to be negative, which means we have complex solutions and no X-intercepts. So we can make that final statement. Anytime your discriminant is negative, you have 0 X-intercepts, but 2 complex solutions. So that is how we use the discriminant. If you have any questions, as always, you can send me an email or talk to your teacher. Until next time, stay safe.